lecture I had started with this chapter, which is nothing but the chemical bonding. And in the chemical bonding, I told you about the definition, what is the need for the formation of the chemical bonding, why different atoms they have a tendency to form the chemical bond, what is the need. And as I discussed, every atom it tends to achieve the octet or the duplet, that means a stable electronic configuration, and that is the reason that chemical bonds are observed. And in the last lecture, I told you about the different types of the chemical bonding, and in that lecture, I discussed about the first type of bond, which is nothing but the ionic bond, which is formed between the two different types of the, can say the atoms. And basically, this ionic bond, it is the definition is which one? The definition tells us that the bond which is formed by transfer of an electron from one atom to the another one. And whenever you say that the bond is formed between the two atoms, and normally the first atom is which one? It's a metal, and the second atom is a non-metal. And as I discussed this particular definition, I gave you some examples. I explained by giving some examples also. And I think in that examples, I told you about the first one, which is sodium chloride, and the second one I discussed was calcium oxide, that is CaO. Now there is one more type of example, which is nothing but the magnesium chloride. And let us finish with the third one, and then we can proceed towards the next type of bond, which is nothing but the covalent bond. Now, in case of the example, which is magnesium chloride, the formula is which one? It is MgCl2. Fine. Now, as this is MgCl2, you can say that this is a metal and this one is a non-metal. So, how the transfer of electron takes place and how it results in formation of an ionic bond between Mg and Cl. So, let us see that particular process in this particular first topic. Now, first of all, let us write down the electronic configurations of both these atoms. Now, magnesium its atomic number is 12. So, it's as it is 12, then we can write down the configuration as 2A2. Fine. Then chlorine, its atomic number is 17. So, we can write down the configuration as 2A7. Now, if you look at the valence electrons present in magnesium as well as in chlorine, then magnesium, it has a tendency to lose 2 electrons, and after losing these 2 electrons, it can result in formation of Mg2+. Fine. And chlorine has a tendency to gain 1 electron so that it can form Cl- anion. Fine. So here, this electron dot structure I can show in this way how this particular bond is formed between the two chlorine atoms and one magnesium. So if suppose this is magnesium atom, how many electrons are there in the valence shell? There are 2 electrons in the valence shell of magnesium. Now plus what is happening? How many chlorines are there? There are 2 chlorines. So one chlorine atom I am writing this side. And how many number of electrons are there surrounding this chlorine? There are 7. So 1, 2, 3, 4, 5, 6, and this is one which is 7. Fine. And there is one more chlorine which is present here, and here also there are electrons present in the valence shell. How many? There are 6 or 7. One more. Fine. Now, what is happening when the bond is formed between the 2 chlorine and 1 magnesium? So, this magnesium atom has a tendency to lose 2 electrons. So, one lost electron will go towards 1 chlorine, and this will achieve the octet, and it will form Cl-. And this one more electron which is still with magnesium, it will go towards which one? It will go towards second chlorine and it will form Cl-. So, magnesium basically is losing both the electrons, and as a result of that, what is happening? We are getting formation of what? We are getting formation of Mg2+, and we are getting 2 chlorines, each chlorine will get -1 charge. So, because of that, what is happening? We are getting 2 Cl- ions generation. So, that is nothing but formation of which particular compound will be there? That is nothing but MgCl2. There is a ionic bond is formed between 2 chlorine atoms and 1 magnesium atom. So, this is nothing but the electron dot structure for magnesium and chlorine, which shows the formation of the ionic bond. Now, let us move towards the orbital diagram for this one. Then we will get a clear idea for the bond formation. Now, this orbital diagram is also very easy, as it is MgCl2. So, what we have to draw by orbital diagram, let us draw magnesium atom at the center and 2 chlorine atoms on the right and left hand side of magnesium. So, if this is magnesium, this is the center, nucleus, then there are 2 electrons present in the valence shell. So, let us draw only the 2 electrons which are there in the valence shell. So, we will not go in drawing all the electrons which are present in the first and the second shell. Or you can make the diagram simpler. You can just draw the valence shell also, so that the diagram becomes very easy. Fine. So, these are the 2 electrons which are present in the valence shell of this Mg. So, this configuration was 2A and 2. Now, what is happening? 2 chlorine atoms are coming. So, on this side, what I will do? I will draw 1 chlorine atom here. This is the first shell. This is the second shell. and this becomes the third shell, or you can say the valence shell of the first fluorine atom. In this valence shell, how many electrons are there? Total electrons are being 7. So this is 1, 2, 3, 4, 5, 6, and this one is 7. Fine, so this is one chlorine atom. Now that side, what is happening? There is one more chlorine atom is present, in which this is the first shell, this is the second shell, and this one is the last shell, in which again we have to show how many electrons. We have to show total 7 electrons. So 1, 2, 3, 4, 5, 6, and 7. Fine. So how this electron transfer will take place from whom to whom? It will take place from magnesium to chlorine. So this is one Mg. So this one electron will go towards which one? It will go towards this one chlorine, and the second electron will go towards second chlorine. And after the formation, what will happen? I'll just make changes in the same diagram, and you can get an idea. After this formation, this configuration becomes 2A. Fine. And as the magnesium has lost 2 electrons, I'll just erase the 2 electrons over here, and there won't be any electrons in the valence shell of this Mg now. And after the transfer of the 2 electrons, now where the 2 electrons will go? They will go to the last shell of the 2 chlorine atoms. That means instead of 7, now this chlorine will be having 8, and this chlorine will also having 8. That means this configuration of both the chlorines will become 288, as well as this side also it becomes 288. And whatever the charges Mg has lost 2 electrons, then this Mg will become 2 plus, and each chlorine will acquire 1 minus charge. That means this complete molecule is a neutral one. 2 plus and 2 minus is neutralized. So the type of the bond between Mg and the 2 chlorines is nothing but which one? It's an ionic bond which is formed by transfer of electrons from Mg to the 2 chlorine atoms. Right? So I hope you understand all these things. I explain all about the ionic bond and how the different molecules are forming, in which the bond present between the two atoms is ionic. First one I talked about NaCl, calcium oxide, and the last example is which one? It is MgCl2. Fine. So this topic is very clear regarding the first type of the chemical bond, which is nothing but the ionic bond present between the two atoms. Transfer takes place from metal atom to the non-metal atom. Now let us go towards the second type of this particular chemical bond, and the second type of the bond is which one? It is nothing but the covalent bond. Now the meaning for the covalent bond, or they may ask you definition for 1 mark, what is the covalent bond or define covalent bond? So it's very easy, just opposite to the ionic bond. The covalent bond is formed by sharing of an electron, or you can say the electron pairs between the two atoms. Now, what is the difference between the atoms which are present in the covalent bond and the ionic bond? In the ionic bond, we see that the transfer is taking place from metal to the non-metal one. But here, in the case of the covalent bond, the sharing of an electron is taking place between the two atoms which are normally both are which one? Non-metal atoms. So it's very clear, there is no transfer here, it is sharing of electrons between the two non-metal atoms. Fine. So this is about the definition of the covalent bond. Now let's see what is the meaning of the one more term which is called as covalency. Now as we discussed last topic is electrovalency. Electrovalency is we about this basically related with the transfer of electrons. And here covalency. What is the meaning of covalency? It is nothing but the number of electron pairs which are shared between the two atoms. So that is nothing but the covalency. And on the same way, we discussed about which term electrovalency for the previous topic, which is nothing but the ionic bond. Fine. Now I clear two definitions, which is the covalent bond as well as the covalency. Fine. And based upon this, they can ask you one more definition. What is the meaning of a covalent compound? So it's very easy. The compound in which the covalent bond is present, which is formed by sharing of an electron pair between the two atoms, which are both normally non-metal atoms. Right? So I hope this introduction is sufficient, so that after this we can start with some examples in which the type of the bond present between the two atoms is which one is a covalent bond. Now, before we go towards the examples of this one, there are two types of this covalent bonds, and one is polar covalent bond and other one is non-polar covalent bond. So let us see what is the meaning of this one. Now, whenever you see, or you can see the types of the compounds of the covalent compounds. So there are two: polar compounds and non-polar compounds, or you can say polar covalent bond and non-polar covalent bond. Now it's very clear, we have done this particular topic. Polar means what is happening, we have done that term which is called as electronegativity. So there is a difference of electronegativity coming between the two atoms. Fine. So in case of the polar covalent bond, electronegativity difference exists between the two atoms. And in case of non-polar, there is no difference of electronegativity between the two atoms. Fine. So you can say that one more difference is that if there is a difference of electronegativity, then there will be a distribution of the charges. Distribution of charges will be there, and we can get positive and negative charge separation in case of the polar covalent bond, and in case of non-polar covalent bond, there will be equal distribution, means there won't be any formation of the negative and positive charges. So for example, suppose I am saying HCl. So what about this HCl? I am saying that this HCl comes under polar covalent compound, or the bond between H and Cl is polar covalent bond. Why? Because these two atoms are completely different. And when we talk about their electronegativity, electronegativity of chlorine is much higher as compared to hydrogen. So what happens, whichever is a shared pair of electron between hydrogen and chlorine will be shifted towards chlorine, and that's why chlorine will get negative charge and hydrogen will get positive charge. Fine. So this forms which one? This forms an example of the polar covalent compound, or the polar covalent bond. Now when we go towards non-polar covalent bond, then non-polar means, suppose I'm taking example of the hydrogen molecule. So hydrogen molecule, what is there? Two hydrogen atoms are joined together to form a molecule, but both the atoms are one and the same. That's why there won't be any charge separation, and this molecule doesn't show any charge separation. That's why you can say that this comes under non-polar covalent compound, and the bond is non-polar covalent bond. So I hope this is very clear. What is the meaning of covalent bond? How this is formed? By sharing of an electron pair. Then what are the two different types, polar and non-polar, and what is the meaning of covalency? That is basically how many number of electron pairs are shared between the two atoms. Fine. Now after finishing with this main concepts, let us go towards the examples of these covalent compounds in which the bond is covalent. Now let us see first of all the non-polar covalent compounds. Now in the non-polar covalent compounds, let us talk about the first molecule, which is nothing but the hydrogen molecule, which is represented as H2. Now we can draw, we can explain this particular hydrogen molecule in number of ways, how this particular hydrogen molecule is formed, or how the covalent bond is formed between the two hydrogen atoms. So let us specifically first of all start with the hydrogen atom. Now hydrogen atom, its atomic number is 1. So if hydrogen atom atomic number is 1, its configuration is naturally 1. So every atom, as I say, has a tendency to achieve the stable electronic configuration. So this hydrogen, as its number of electrons are 1, it tries to achieve the stable configuration by achieving duplet. That means it will try to achieve the configuration of the nearest noble gas, which is that one, helium. Helium is having 2 electrons in the valence shell, which is a duplet. So hydrogen always tries to gain that duplet configuration, that is number of electrons in the valence shell 2. Now if it wants to achieve that particular duplet configuration, and if it wants to form this hydrogen molecule, how the process will be happening? Then in that case, what will happen? Each hydrogen atom, because here this is hydrogen molecule, right? So hydrogen molecule, how do we have to show? Because it's a covalent bond, H single dash H, right? Now each hydrogen atom, it contributes 1 electron to give 1 shared pair of electron between the two hydrogen atoms. Understood? Each hydrogen atom is contributing 1 electron, which results in formation of 1 shared pair of electron between the two hydrogen atoms. Means basically, after sharing 1 electron pair between the two hydrogen atoms, we are getting formation of a single covalent single covalent bond between the two hydrogen atoms. That means, suppose I am saying that before combination, these are the two hydrogen atoms. Fine, H and H. So what does this mean? This means a single electron is present on each hydrogen atom. This was before combination. So once after combination, what will happen? Once after combination, each hydrogen atom is contributing the single electron, so as to form 1 electron pair with another hydrogen atom. So after combination, the two hydrogen atoms, we can show it in this way, like this, right? So the meaning of this thing is that it is forming this is nothing but not the shared pair of electron between the two hydrogen atoms, or you can just write down this as H1, H single bond H. So this is nothing but not a single covalent bond has been formed between the two hydrogen atoms. So this is simple representation. This is before combination, and this is after combination of the two hydrogen atoms. Right? Now Now you can show the same representation by drawing the orbital diagram also. How to draw the orbital diagram? Now, orbital diagram also is very easy. In the same way, we have drawn the diagrams for the previous one, that is ionic bonds we have to show. Now, if this is hydrogen atom, suppose the nucleus. Now, there is only one shell in which one single electron is present. Over here is the atomic number 1. Now, this is before combination. Now, this is again the second hydrogen atom, and this is one electron present in the last shell. So what is happening? This one electron, each hydrogen atom is contributing one electron with the other hydrogen atom, which results in formation of one electron pair between the two hydrogen atoms. Right? So this is two hydrogen electrons are in the shared between the two hydrogen atoms, and here between formation of which molecule? The molecule we can represent in this way. This is the hydrogen atom, its nucleus, and the last shell, which is the valence shell. And now we can join the two atoms together to show the formation of this particular hydrogen molecule, in which now what is happening? The two electrons are now getting shared between the two atoms, right? So whichever is the shared electron or shared pair of electron, we can show it in this way. And this is nothing but what? This is nothing but hydrogen single bond hydrogen. That is, between the two atoms of hydrogen, we are getting formation of a single covalent bond. That means you can represent covalent bond formation or the covalent compound in both the ways, and it's just the electron dot structure, or you can show the orbital diagram also. You can go for both the ways. Both the ways are very easy. Right? So this is clearly the first example, which is a non-polar covalent compound, which we discussed is which one? Hydrogen. That is nothing but H2. There is only one electron pair which is shared between the two hydrogen atoms. Right? Then after that we go for the second molecule, which is nothing but chlorine. Chlorine molecule we are going to write down as Cl2. And Cl2 means there is a single covalent bond which is present between the two chlorine atoms. Now as we wait for the previous procedure, in the same way we have to go for the chlorine molecule covalent bond procedure. Now here, first one, let us write down the electronic configuration for the chlorine atom. Now chlorine, its atomic number is 17, and as its atomic number is 17, the configuration becomes 287. Now there are both atoms which are present over here is chlorine. Now as 287 means how many electrons are there in the valence shell? There are total 7 electrons present in the valence shell. Now first of all, find out what is the tendency for the chlorine atom. Now chlorine atom, as there are 7 electrons, it is easy for chlorine to gain 1 electron and achieve the octet. That means each chlorine, what it will do, both the chlorine atoms will contribute 1 electron to form 1 electron pair between the two chlorine atoms. So each chlorine atom is contributing single 1 electron with the other chlorine atom, so that we are getting formation of a single electron pair between the two chlorine atoms. Right? So here how to show the structure formation of this chlorine molecule by electron dot structure. Let us see, this is chlorine. Now chlorine, we just have to show the valence electrons. That means 7 electrons present in the last shell. So these are the 7 electrons. This is 6 and this is the last electron. Now plus there is one more chlorine atom which is coming, and there are again 7 electrons present. So this is a representation, electron dot representation before combination. Now after combination, what is happening? This chlorine is getting combined with this one. So each chlorine is contributing one electron. So both these electrons are getting shared between the two chlorines, and after sharing, what will happen? We can just show the formation of the chlorine molecule, in which we can show that because particular 2 electrons are getting shared between the two chlorine atoms in this way. So this is nothing but shared pair of electron between the two chlorine atoms. Or you can write down the same example in this way. Instead of the 2 electrons, you can just draw one single dash, which is nothing but a single covalent bond which is formed between the two chlorine atoms, which generates the covalent bond between the two chlorine atoms, which is nothing but a chlorine molecule. Now you can draw the orbital diagram also for this particular chlorine molecule, and orbital diagram also, that is very easy. It is the before and after combination, you can just draw it. So first of all, let us see before combination. This is the central nucleus, and these are the different shells which are present in the chlorine. First shell, this is second shell, and this is the last shell, in which the total number of electrons present are only 7. We are going to just draw the number of electrons in the valence shell, not in the first and second shell. So in the same way, you can draw the second chlorine atom, this central nucleus. This is the first shell, this is the second one, and this one is the last shell, or you can say this is the valence shell. Now I am showing that this is the diagram before combination. So total number of electrons are 7. So 1, 2, 3, 4, 5, 6, and this is the one electron which is presented here. In the same way, I am drawing the total number of 7 electrons in the balance sheet for the second chlorine atom. Now, before combination, what is happening? Whichever these two chlorine atoms are there, so they are having one electron in the balance sheet. So each chlorine atom is contributing one electron, so that we can generate formation of one electron pair between the two atoms. So this electron is shared with this electron of the second chlorine atom. So sharing of one electron between the two chlorine atoms. So after this combination, what is happening? I just make changes in the same diagram, and I will just draw the diagram. After combination, means we are getting formation of the chlorine molecule. So I can just show over here, that is, once this particular chlorine atom, second chlorine atom is combining with the first one, then after combination, what you have to draw is the second shell, last shell. You can just mix up with the last shell of the first chlorine. Then this becomes the last shell. This is the second last shell, and this is the first shell of this particular chlorine atom, second chlorine atom. So in this way, whichever the 7 electrons are there, so these are the 6 electrons, and this one is the 7th electron of both the chlorine atoms. Means whichever is these 2 electrons. Now I can say that these 2 electrons are shared between the 2 chlorine atoms, and I can just write down that chlorine is forming a single covalent bond with the other chlorine atom. Means you are getting a single bond between the 2 chlorine atoms, or you can say that the covalency is 1. How many number of electron pairs are shared between the 2 atoms is nothing but the covalency. So in this way, we discuss the first 2 non-polar covalent compounds. The first one is the hydrogen we saw, and the second one we saw is nothing but the chlorine. Now in the same way, we can go further another molecules which are oxygen and nitrogen. By this oxygen and nitrogen, here the number of covalent bonds are a little bit more as compared to the first one. In the first 2, what we saw, hydrogen, chlorine, the number of covalent bonds are only 1. H single bond H, chlorine single bond chlorine. That is covalence is 1. But when you go for oxygen, that is O2, then in the case of oxygen, you have to show the diagram in which there is a double bond coming between the 2 oxygen atoms. It's a double covalent bond. And when you go for nitrogen, that is, it is N3, so it will be N triple bond, and there is a triple covalent bond is coming between the 2 nitrogen atoms. Right? Now, whenever I am saying that this is O2, that is the oxygen molecule, then oxygen molecule it is formed by formation of sharing of 2 electron pairs between the 2 oxygen atoms, and nitrogen is formed by sharing of 3 electron pairs between the 2 nitrogen atoms. So let us see first of all this oxygen. Oxygen is having atomic number. How much it is there? Atomic number. Suppose I am writing over here, it is 2, 6. That means each oxygen it wants to gain 2 electrons so that it can achieve the complete octet. Right? If it is like this one, a second oxygen atom is also one and the same. So what will happen? Each oxygen atom it will share how many electrons with another oxygen atom? It will share 2 electrons with another oxygen atom, and because of the sharing of the 2 electrons, it will result in formation of what? It will result in formation of a double covalent bond. Whatever may be the number of electron pairs shared between the 2 atoms, on the basis of that we can find out the number of covalent bonds which are present between the 2 atoms. In the previous example, in the hydrogen and chlorine, both the atoms were sharing only 1 electron pair. That's why there was only one single covalent bond. But here what is happening? Here in this case, each oxygen atom needs 2 electrons. So both the atoms will share 2 electrons with each other so that we can get a double covalent bond between the 2 oxygen atoms. Right? So in detail we will see this particular process of formation afterwards in the next lecture, oxygen as well as nitrogen.